There is a forest in southwestern Germany that has been studied by geologists, archaeologists, and physicists for over a century. And the more carefully they look at what lies beneath it, the less it fits the explanations they arrived with. The Black Forest, known in German as the Schwarzwald, stretches across approximately 6,000 square kilometers of Baden-Württemberg in the southwestern corner of Germany. From above it is dense, dark, and almost unbroken. A wall of fir and spruce so thick that in certain sections the canopy closes entirely and the forest floor beneath it sits in a permanent green twilight even at midday in midsummer. From the outside it looks like exactly what it appears to be. A very large, very old, very dark forest. What is underneath it is something else entirely. Researchers who have spent careers studying the geology, archaeology, and deep history of this region will tell you that the Black Forest sits above one of the most geologically complex and least understood zones of the European continental crust. That the archaeological record preserved in its soil and beneath its ancient riverbeds is still producing findings that revise what was previously understood about human presence in this part of the world. And that the most recent investigation, using technology that was not available even a decade ago, found something beneath this forest that nobody expected to be there. The findings are documented. They are published. They are real. The problem is that nobody has put them all in the same place before. If you are new here, this channel covers history and ancient discovery that most people were never properly taught. Subscribe now and let me know in the comments below what you already knew about the Black Forest before watching this video today. Let us start with the geology. Because what sits beneath the Black Forest is, before you add anything else to it, one of the most geologically unusual foundations of any major European landscape. The Black Forest is not simply a forest sitting on top of ordinary European soil. It is a forest sitting on top of a raised block of ancient crystalline rock known as the Black Forest Massif, a fragment of the Variscan mountain belt that formed during a major collision of continental plates roughly 300 to 350 million years ago. The Variscan Mountains were once among the largest mountain ranges on Earth, comparable in scale to the modern Himalayas. They have since eroded almost completely away. What remains in the Black Forest is their root. The same deep geological structure that Uluru represents in the Australian context, the exposed and eroded foundation of something far larger that no longer exists above the surface. The rock at the core of the Black Forest Massif is granite and gneiss, some of it among the oldest exposed rock in Central Europe, dating back in places to over 500 million years. This ancient crystalline basement was pushed upward along fault lines during a later phase of geological activity, lifting the entire block relative to the surrounding landscape and creating the elevated plateau that the forest now covers. To the east of the Black Forest, the same geological forces that lifted the Massif created its mirror image. The Swabian Alb. Between them, the Rhine Valley dropped down along the same fault system, creating the flat river plain that separates the two elevated regions today. This geological structure, a lifted block of ancient crystalline rock sitting above a deep fault system, has consequences that reach far beyond landscape formation. And those consequences are what recent research has been systematically documenting. The first significant area of recent scientific finding involves what lies directly beneath the forest in the upper layers of the geological record. Not millions of years beneath the surface. Tens of meters. Within reach of standard excavation equipment and ground-penetrating radar. Archaeological surveys conducted across the Black Forest region over the last 2 decades, combining traditional excavation with LiDAR aerial mapping and ground-penetrating radar surveys, have produced a picture of pre-Roman and pre-Celtic human activity in this landscape that is significantly more complex than was previously understood. The standard archaeological picture of the Black Forest before these surveys was relatively simple. Scattered evidence of human presence from the Mesolithic period onward, intensifying through the Bronze Age and Iron Age, with the Celts leaving the most visible traces in the form of hill forts and burial mounds before Roman expansion brought the region into the recorded historical record around the 1st century BC. That picture was not wrong. It was incomplete in ways that the surveys have now begun to fill in. LiDAR surveys, which use laser pulses from low-flying aircraft to map surface features beneath vegetation cover, have revealed across the Black Forest region a density of archaeological features that was entirely invisible before this technology was applied. Beneath the forest canopy, beneath centuries of leaf litter and soil accumulation, the LiDAR returns show a landscape that has been modified, organized, and used by human hands on a scale that no surface survey had previously suggested. Enclosures. Earthwork boundaries extending across areas of several hectares. Trackways running between sites that have no corresponding surface features visible to ground-level observation. Mound structures in forest clearings that were previously recorded, if at all, simply as natural ground irregularities. And beneath several of these features, when ground-penetrating radar was applied, void spaces. Chambers. Hollow areas beneath the earthwork surfaces that the radar returns indicate are not natural geological features but constructed spaces sealed beneath accumulated soil. The excavation of several of these sites has produced findings that extend the evidence of complex human organization in the Black Forest significantly further back in time than the previous record suggested. Artifacts recovered from sealed contexts beneath earthwork features have been dated using optically stimulated luminescence techniques to periods reaching back beyond 5,000 years in some cases. 5,000 years of deliberate landscape organization in a region that the previous archaeological model described primarily as peripheral wilderness until the Iron Age. That revision alone would be significant. But it is what the deeper surveys have found that has produced the most unexpected results. Now let us talk about what lies further down. Because below the archaeological record, below the soil layers, below the immediate subsurface that conventional archaeological methods reach, the geological surveys of the Black Forest have documented something that has been the subject of serious scientific investigation for over a decade and has received almost no public attention whatsoever. The Black Forest Massif sits above a deep fault system that connects through the Rhine-Graben structure to one of the most geologically active zones in Central Europe. This fault system is not dormant. It generates measurable seismic activity regularly, producing small earthquakes that are recorded by the dense network of seismic monitoring stations maintained across southwestern Germany, Switzerland, and eastern France. What the seismic monitoring network has documented, in data that has been accumulating since the network was established and that researchers at the Karlsruhe Institute of Technology and the University of Freiburg have been analyzing in increasing detail over the last 15 years, is that the fault system beneath the Black Forest behaves in ways that are not fully explained by standard models of European tectonic structure. The fault geometry at depth, revealed through the analysis of seismic wave patterns from both natural earthquakes and controlled seismic sources, shows a structural complexity that was not apparent from surface geology or from the earlier, lower-resolution surveys. There are zones within the fault system where the physical behavior of the rock deviates from what the surrounding geology would predict. Zones of unusual fluid movement along fault planes. Zones of anomalous heat flow. And in one specific area beneath the central Black Forest Massif, a zone where the seismic wave velocities indicate the presence of a body of material at depth whose physical properties do not match anything else in the regional geological record. The researchers who have documented this anomaly have been careful in their published language, as researchers typically are when findings do not fit established frameworks. The anomalous zone is described in the literature as a region of uncertain composition requiring further investigation. Its depth is estimated at between 15 and 25 kilometers below the surface, placing it well below the upper crust and within the zone where the boundary between the lower crust and the upper mantle begins. At those depths, the physical conditions are extreme. Temperatures measured in hundreds of degrees. Pressures that would crush any material familiar from surface experience. The behavior of rock under those conditions is genuinely different from its surface behavior, and the tools available for investigating it are limited to the indirect methods of seismic analysis and the sparse information recovered from deep boreholes drilled at other European locations. What the anomalous zone beneath the Black Forest appears to represent, based on the seismic data and the thermal measurements, is a region where deep crustal or upper mantle material has been placed at unusually shallow depths by the geological processes that lifted the Black Forest Massif. A region where material that would normally sit 40 or 50 kilometers below the surface has been brought to within 15 to 25 kilometers of it by the same tectonic forces that created the elevated landscape visible today. The implications of this are not primarily dramatic. They are primarily scientific. But they are significant. It means that the energy and fluid systems that circulate through the deep earth are, beneath the Black Forest, closer to the surface than almost anywhere else in Central Europe. It means that the thermal and chemical conditions that drive deep geological processes are operating at depths that are, in relative terms, accessible to investigation in ways that would not be possible in regions with more conventional crustal structure. And it means that the surface effects of those deep processes, the seismic activity, the thermal springs, the particular chemistry of the groundwater that emerges from the Black Forest's many spring systems, are expressions of geological dynamics operating from far deeper sources than was previously understood. The thermal springs of the Black Forest are among the most significant in Central Europe. The spa towns of Baden-Baden, Bad Wildbad, and Bad Herrenalb, among others, are built around spring systems that have been used continuously since Roman times and almost certainly long before. The Romans valued them enough to build permanent stone infrastructure at several sites, and the archaeological evidence of pre-Roman use extends back to the Iron Age at minimum. What drives those springs has been investigated in detail by geologists studying the regional hydrology. The water emerging at the surface has characteristics that reveal its origin. The temperature, the chemistry, the isotopic composition of the dissolved minerals, all of these carry information about how long the water has been underground, what rock formations it has moved through, and from what depth it has ascended. The analysis of the Black Forest spring waters shows that some of them have been circulating underground for periods measured in thousands of years, moving slowly through the fractured crystalline rock of the massif before emerging at the surface. The depth from which the deepest circulation systems draw their water, estimated from the temperature and chemistry of the emergent spring, reaches into the lower portions of the upper crust. These are not shallow groundwater systems. They are deep circulation systems driven by the unusual thermal structure of the crust beneath this region. The spring at Baden-Baden emerges at a temperature of 68 degrees Celsius. The heat source for water at that temperature, emerging from crystalline rock in a region with no active volcanism, is the anomalously elevated heat flow from the deep crustal zone documented by the seismic surveys. The surface and the deep are connected here in ways that are measurable, physically real, and only recently fully understood. Now let us talk about what the archaeological record, when combined with the geological findings, suggests about the human history of this place. The Black Forest has been continuously occupied for at least 10,000 years. That figure is established by the archaeological record available before the recent LiDAR surveys, and the LiDAR work suggests the real figure of meaningful human presence may be considerably longer. The region was attractive to human settlement not despite its density and darkness but because of specific resources it offered that were unusual in the broader European context. The thermal springs were one. Reliable hot water is a significant resource in any pre-industrial landscape, and the spring systems of the Black Forest offered that resource consistently across seasons in a way that would have made specific locations within the forest disproportionately significant as gathering places, trading locations, and eventually sacred sites. The mineral resources were another. The granite and associated metamorphic rocks of the Black Forest Massif contain or deposits that have been worked intermittently since the Bronze Age and intensively since the medieval period. Silver, lead, copper, and iron have all been extracted from the Black Forest at various points in history, and the evidence of pre-Roman mining activity recovered from several locations in recent decades indicates that knowledge of these deposits predates the historical record by a significant margin. But the resource that recent research has identified as potentially the most significant driver of long-term human attachment to this specific landscape is one that was not recognized until geophysical survey technology revealed it. Beneath the Black Forest, within the fault system that connects the surface to the deep crustal anomaly documented by the seismic surveys, there are zones of anomalous electromagnetic activity. The movement of mineralized fluids through fractured rock along fault planes generates measurable electromagnetic fields. These fields have been documented at the surface in surveys conducted across the region, and they correspond in their spatial distribution to the fault geometry mapped by the seismic studies. The electromagnetic fields produced by deep fluid movement in fault systems are real, physically measurable, and in specific frequency ranges known from separate research contexts to have effects on human neurological function similar to those documented at Uluru. Very low-frequency electromagnetic fields interact with the human nervous system in ways that are understood biophysically, and exposure to fields of certain characteristics and intensities produces measurable changes in perception, emotional state, and cognitive processing. The zones of strongest electromagnetic field activity in the Black Forest correspond, with a frequency that is difficult to attribute entirely to coincidence, to locations that have been treated as significant or sacred in the long human history of this region. The Roman temple sites. The locations of pre-Roman Celtic ritual deposits recovered by archaeologists. The spring sites that have been associated with healing and spiritual significance since before any written record of the region exists. And in several cases, the locations of the underground chambers and sealed earthwork features identified by the recent LiDAR and ground-penetrating radar surveys. This correspondence does not require a supernatural explanation. It requires a straightforward one. The people who lived in this landscape for thousands of years before the modern period were more sensitive to its physical characteristics than their successors gave them credit for. They located their significant sites where the physical properties of the landscape produced effects that were perceptible to human senses, even if those people had no framework for understanding the geophysical mechanisms behind what they were experiencing. The most sacred locations in the long human history of the Black Forest were sacred because something real was happening there. Something physical. Something that the most sensitive individuals in each generation could perceive and that accumulated cultural significance around it over time. Modern instruments have now measured what those individuals were perceiving. The deeper survey conducted in 2019 and 2020 by a collaborative team from the Karlsruhe Institute of Technology, the University of Basel, and the Federal Institute for Geosciences and Natural Resources in Germany applied a combination of magnetotelluric imaging, passive seismic monitoring, and deep groundwater geochemistry to the central Black Forest region in a survey that was the most comprehensive geophysical investigation of the area ever undertaken. The results of that survey are published across several technical papers in geophysical journals. The combined picture they produce has not been synthesized in any public-facing document before this. What the 2019 to 2020 survey found was that the deep crustal anomaly previously identified from seismic data is real, is larger than earlier estimates suggested, and is connected to the surface through a system of fault-controlled fluid pathways that create measurable surface effects in electromagnetic, thermal, and geochemical terms across a zone covering the majority of the central Black Forest Massif. The anomalous zone at depth is now interpreted by the researchers who have studied it most closely as a region of partial melt, material in the lower crust that is not fully molten but that exists in a state intermediate between solid rock and magma, held at that state by the balance of heat from below and pressure from the overlying crust. Such zones are known from other geological contexts globally, and they have significant implications for the long-term geological behavior of the region above them. A zone of partial melt at 15 to 25 kilometers depth beneath a region of elevated topography maintained by deep tectonic forces is a geological system in a state of dynamic balance. It is not going to erupt. The depth is too great and the degree of melting too partial for the kind of volcanic activity that produces surface eruptions. But it is also not static. It generates heat. It drives fluid circulation. It sustains the electromagnetic fields that the surface surveys have documented. And it has been doing all of these things, on geological timescales, for as long as the Black Forest Massif has existed in its current elevated form. The ancient crystalline rock that forms the visible substance of this landscape, the granite outcrops that emerge from the forest floor, the boulders in the stream beds, the cliff faces in the deeper valleys, these are the surface expression of a system that extends from the forest floor to depths that no drill has ever reached in this region, driven by heat from a partially molten zone more than 15 kilometers below. What the people who lived here for 10,000 years before anyone thought to measure any of this were standing on was not a passive landscape. It was an active one. A landscape driven from depth. A place where the deep earth was closer to the surface than almost anywhere else in Central Europe, and where the effects of that proximity were real, perceptible, and significant enough that they shaped the entire human history of the region. The thermal springs that the Romans built their finest German spa infrastructure around. The ore deposits that made the Black Forest one of the most important mining regions of medieval Europe. The electromagnetic zones that the long sequence of people who held this land as sacred located their most significant sites on. The unusual density of pre-Roman archaeological features that the LiDAR surveys are now revealing in unprecedented detail. All of it driven by what sits beneath. All of it expressing, at the surface, the nature of what lies 15 to 25 kilometers below the forest floor in a zone of partial melt that no one living on the surface above it had any way to know was there. Until the instruments that could measure it were built and pointed in the right direction. The Black Forest is not simply a forest. It is the surface of something that extends far deeper than its trees, far older than its oldest recorded history, and far more geologically active than its quiet green exterior suggests. The scientists who have spent careers studying what lies beneath it will tell you that the most significant findings are the ones still coming. That each survey season produces a clearer picture of the deep structure. That the full implications of what the 2019 to 2020 survey revealed are still being worked through. And that the landscape the ancient peoples of this region treated as sacred, on grounds that no written record fully explains, turns out to have been extraordinary in ways that are only now becoming measurable. What is beneath the Black Forest has shocked the researchers who have spent careers studying it. Not because it requires abandoning the frameworks of geology and physics, but because it confirms, with the precision of modern instruments, something that the long sequence of people who lived here before the modern world arrived understood in their own terms, in their own way, across a span of human presence that makes the recorded history of this region look like the most recent paragraph of a very long story. The forest above is dark and dense and very old. What is beneath it is older still. And the scientists who have looked most carefully at it are only beginning to understand what they are seeing. If this changed how you think about the Black Forest, let me know in the comments below and subscribe for more history that most people were never properly taught.